This is Lab 2, Magnetic Fields by Ben Skalka. Starting with the introduction and purpose. This lab involved observing and measuring the field of a magnet along with its interactions with other objects. Then we calculated the magnetic moment and field and represented it with a computational model. Moving on to the fundamental models used in Lab 2. The equations in this lab are the Biot-Savart law, Newton's second law, and the magnetic field of a bar magnet. You can see these equations listed here. We've got the magnitude of the magnetic field of a bar magnet with K r to the n. Then we've got the Biot-Savart law for magnetic field. And then we have Newton's second law, which was used in the previous lab as well. Moving to the experimental model. Our experimental model defined the magnet as the system and everything else as surroundings. The magnetometer in the phone was calibrated to magnetic north, and we found the off-axis magnetic field of the bar magnet. The magnetometer measures 0 in the x direction when the magnet is far, and it increases as the magnet gets closer. So when it's considered a far distance away, denominator gets really big, goes to 0. As it increases, S or R, the vector gets smaller, and the number gets bigger. Calculating the field. Here we plotted the data for the on-axis field and distances from magnet for multiple values and linearized the slope n and intercept ln of k. Here you can see the plotted and equations for the linearized slope and for different r values to represent different distances away. Moving on to the computational model. Here you can see some of the code. Some of the most important parts are the equations for the magnetic field of the dipole, and we use that by setting the observation location for those equations equal to r perpendicular, which is just the distance perpendicular to the dipole. And here you can see the values that we got. So essentially, at 45 degrees, the distance away is listed there. I'm not going to read out the whole thing. Moving on to what if. What if you hadn't oriented your experiment to compensate for magnetic north and had instead laid out your meter stick at some intermediate angle with respect to Earth? So essentially, what if it wasn't calibrated? What if we just put it right there? Well, if the orientation wasn't correct, we would have seen different x and y components of the ambient electric field, and the magnetometer's readings would have been different by this certain amount in whatever angle's direction. This would be because of the Earth's magnetic field, and it wouldn't be aligned with the magnetometer, so we wouldn't be able to get an accurate aligned result. Moving to what if you were to stick two identical magnets together and rerun the experiment? Well, this one's pretty easy. The magnitude of the measured field would increase because the magnetic field would combine and create constructive interference and overall increase the field, therefore increasing the magnitude of the measured field, which I said before. Finally, possible sources for error. Well, we may not have accurately found the magnetometer's position in the phone because it's variable, and we were just kind of eyeballing it. We could have bumped the phone out of alignment with Earth's magnetic field, and therefore doing what we said in the first what if, which would make the x and y components inaccurate. Other objects may have affected the magnetic field around the phone, so for example, like having a computer around, anything else that could have disrupted,